right, so we're going to actually plot some lines now. The method we're using is sometimes called the three-point method. We use 3 points to graph the line. We find 3 ordered pairs solving the equation. We plot the ordered pairs, and then we draw the line passing through the points. I have a coordinate system already set up, and we're good to go. I've got some examples. Here we go. 3x minus 2y is 0 as a linear equation. And we'd start with maybe setting x or y equal to 0. Let's try that. Try to make a table. Try x equal to 0. Then you get 3 times 0, because you get minus 2y is 0. So that makes y 0. So that means this line is going to pass through the origin. Oh, we didn't say that before. The point 0, 0 is called the origin. So that's 1 point, but there's lots of lines that go through the origin, so we need a little more to go on. Let's try picking something else. You could pick x or y. Now try picking something for x. Oh, I don't know what to pick. Maybe I got to make sure we stay in here. But not make too big a number, because I've already set up my x-axis not to be very big. So we'll try maybe x equal to 2. X is 2, I get 3 times 2 minus 2y is 0. 6 minus 2y is 0. And that could be minus 2y is minus 6. That's y equal to 3. So we'll do that. Let's make sure that works. So x is 2 makes that 6. X is 3 makes that minus 6. And 6 minus, okay, we're good. And then we'll try another one. We'll try some negative numbers for x. Maybe minus 1 for x. See what happens. So then it's 3 times minus 1 minus 2y is 0. Minus 3 minus 2y is 0. Minus 2y is 3. Y equals minus 3 halves. It's a fraction. It's negative. We'll see if this makes sense in a minute. Okay. So if everything has gone according to plan, when we plot these, they'll all line up in a line. So we've got 0, 0 already plotted. We'll go 2, 3, that's up here. We'll go minus 1, minus 3 halves down here. So x is minus 1, y is minus 3 halves, minus 1 1/2 right here. Seems like we haven't made a mistake there, so we'll just go ahead and sketch in the line connecting those points. In theory, this line extends forever in each direction. And every point that's on the line, if we could read the coordinates off of it carefully, the x and y would solve 3x minus 2y is equal to 0. Okay. So that's the plan. We have a couple of special equations here that don't have both x and y in them. Here's one of them. What's it look like? 5x is 10. Ordinarily, if you saw 5x equal to 10, you'd say, well, x is just 2. I don't see a y. And so the context of the question is important. In this particular question, you have to be told that you're trying to draw the graph of the line whose standard form is 5x equals 10. We're allowed the coefficients of x or y, one of them to be 0, so it's 5x plus 0y is 10. What that means is, since it doesn't specify anything for y, y can be any number. If we solve this, we get x equal to 2. But y can be anything. So we make a table of values. X, y. X is 2, y is anything. Like that. And we plot those. Maybe I'll try changing to another color. This will be a challenge for me. Okay. Here we go. X is 2, y is 0, that's here. Doesn't look like it's going to be showing up very well. What else could I do? This one here. It looks the same as our color. Okay, we'll just go for it. X is 2, y is 0. That's right here. X is 2, y is 4. 2, 4, up there. Kind of cool looking. And then x is 2, y is minus 3. That's down here. So these line up vertically, since they all have the same x coordinate, they all lie above x equal to 2. I should probably label these things. So this one here is 5x equals 10. And this one here is 3x minus 2y is 0. And I also have an equation that just has a y in it. You might guess what happens then. Whereas y equals minus 3. That's ax plus by with a equal to 0. So 0 times x. And then b equal to 1, so 1 times y. And then c equal minus 3. And following the thinking of the previous example, if I make a table, all the y's are minus 3. Make 3 of them. Pick anything you want for x. 2, 0, minus 4, say, for x. There we go. And then we're going to draw these. Y is minus 3 all the time. So here's the minus 3. Oh, here's one here too. Did we get that before? Oh, look at that. There it is. So here we go. Those are the places where y is minus 3. Oops, stretch myself across here. And so we want to find when x is 2. Well, there it is again. So x is 2, y is minus 3 is there. X is 0, y is minus 3 is over here. And x is minus 4, y is minus 3 down here. And so we've got those lining up as a horizontal line. I'll just try to sketch it in. Off we go. And we'll label that one. It's the line with equation in standard form, y equals minus 3. Okay. So basically, those are the three kinds of things that can happen. You can have a horizontal or vertical line, or one that's not. The horizontal and vertical lines, the equations, they don't have the other variable in them. If both variables are present, it won't be horizontal or vertical. And if it's not horizontal or vertical, you can just create the, well, maybe they're not two intercepts. Here's one with just one intercept. But you can use the intercepts to your advantage. With these horizontal and vertical lines, you can just see what's going on. The x is always the same number, y can be anything, or here y is always the same number, x can be anything. All right, I'm having fun so far, but there's still more to come. Getting the board cleaned off between illustrations of topics is starting to wear on me, but whatever. I'm happy to be here. Here we go.